Good morning, children. So last class நம்ம two examples methods of producing induced EMF படிச்சோம். Then we discussed the production of induced EMF. Two methods we discussed. One is relative motion between the circuit and magnet, and second method the variation in current flowing through the nearby coil. Both the experiments we discussed earlier at the starting of this unit. என்று நம்ம படிச்சிருந்திருக்கோம். Then production of induced EMF by changing the area of the coil. ஒரு கண்டக்டர் வந்து மேக்னெட்டிக் ஃபீல்டில் பிளேஸ் ஆகும்போது அதோட ஏரியா சேஞ்ச் ஆகுது. ஸோ பை சேஞ்சிங் தட் ஏரியா ஹவு மச் கரண்ட் இஸ் ப்ரொடியூஸ்டு த என்ன எஃபெக்டில் அதில் நடக்குது, எவ்வளோ இஎம்எஃப் ப்ரொடியூஸ் ஆகிறத நம்ம வி கால்குலேட்டட். அட் லாஸ்ட் யூஸிங் த ஓம்ஸ் லா we found a equation to find the current I is equal to BL divided by R as the equation number 4.19. ஞாபகம் இருக்கா? குட். இதுதான் நீங்கள் ஹோம் டெஸ்ட் எழுதுனீங்க, ஹோம்ஒர்க் டெஸ்ட்டாக. And now following the equation 4.19, here we will discuss about the energy conservation. Okay, and energy conservation we are going to derive the equation for that. The rod, current carrying rod வந்து movable rod AB is kept in a perpendicular magnetic field. Now it experiences some force in the direction of outward which is acting opposite to the motion. Then we can write the force. So we are using the formula from the magnetic Lorentz force. FB vector is equal to IL vector cross B vector. That equation can be written here as BIL sin theta. And already we know it is acting perpendicular, then theta will be taken as 90 degree. So in order to move the rod with the constant velocity V vector, the constant force we can say it is equal to opposite to the magnetic force. The constant force is equal to what? Opposite to magnetic force. Then we can write the equation mod of F vector applied force is equal to magnetic field force FB vector. That is equal to, we can write as BIL. Rendu equal, then we can write both the equations are same. So we can say the mechanical work is done, applied force to move the rod. So we are giving some mechanical work. Then we are giving some work done. That rate of doing work or power, we can write the formula P is equal to F into V. இது நம்ம லாஸ்ட் இயர் படிச்சிருந்திருக்கோம். Okay, the work or power we used in 11th standard. Power is equal to force into velocity. Okay, and that we are writing the F vector F dot V vector is equal to F applied force V cos theta because of the dot product. The dot product என்றதால we are taken as cos theta. And theta is 0. Since theta is 0, then we can write the equation will become ILBV. So F applied force expansion we can write as ILB. We are substituting in this. Then it will become ILBV. Okay, and see the next step. So from the previous derivation, previous 5-mark question, we are substituting the I value. So what I we got from the equation 4.19, what equation we are using? From the equation 4.19, the I value substituted in this equation. So in 4.19, we got the I value as BLV divided by capital R. What equation we got? BLV divided by capital R. We are substituting in this I. Then BLV divided by R, rest is LBV. And now B and B, L and L, B and will multiply. Then the equation will become B square, L square, V square divided by capital R. Okay, and this is what? This is power. And here induced current flows in the loop and Joule heating takes place. We know the Joule's law of heating. Whenever the electric current is passing through the conductor, some heat will be produced because of the resistance. That heat value is equal to I square R into T. And now we are using that, and here due to the Joule heating effect, some thermal energy takes place. It is dissipated in the loop, and that we are calculating here. P is equal to I square into R. So I square, once again we are substituting from the equation number 4.19. இப்போ I நம்ம இதிலிருந்து எடுத்திருக்கோம், 4.19 இலிருந்து இதில் substitution பண்ணுறோம். Then it is I square, then we can write BLV by R whole square into R. B square L square V square divided by capital R into R. Okay, this is what? This is power. The equation is 4.21. It is like it is same like a 4.20. So what we got in to 4.20, P is equal to B square L square V square by R. In this Joule's heating, after substituting the I value, we are getting the same equation. So comparing these two equations, these two are same. Okay, so these two are same. We can say now the mechanical energy is needed to move the rod to converted that mechanical energy is converted into electrical energy, which then appears as the thermal in the loop. This energy conversion is consistent with the law of conservation of energy. So mechanical energy is converted into what? Electrical energy. So with the help of mechanical energy only we can move the rod, and that only is converted into the energy. This is called as conservation of energy. Okay, so that we got here in this conservation of energy. Have you understood, children? Yes, good. And now example 4.14. Okay, after the detailed question, here we are discussing about example 4.14. And in this, you see the question is a circular metal of area 0.03 meters square. It rotates in a uniform magnetic field of 0.4 Tesla. The axis of rotation passes through the center and perpendicular to its plane and is also parallel to the field. If the disk completes 20 revolutions in 1 second and the resistance of the disk is 4 ohm, we have to calculate the induced EMF between the axis and the rim and induced EMF current flowing through the disk. So first we are writing the given datas. A is equal to 0.03 meters square and B is 0.4 Tesla and F is 20 rotation per second. Then resistance is 4. And now we can write the formula. Area swept out by the disk in unit time is equal to area of the disk into frequency. So area swept we can write as dA divided by dt. That is equal to area of the disk is 0.03 into frequency is 20. Then we got area swept by the disk in unit time is 0.6 meters square. And the magnitude of induced EMF, we can write the formula, the known formula. Epsilon is equal to d phi b divided by dt. So phi b can be substituted. நம்ம phi b நிறைய டைம் யூஸ் பண்ணிருக்கலாம், b vector, dA vector or ba cos theta. Okay, so in that theta is 0, then we can write as ba here, dba divided by dt, that we can reduce to b dA divided by dt. Okay, and now we are writing the epsilon, substituting the value 0.4 into 0.6 divided by 1 because dA by dt is 0.6. That we can write as 0.24 voltage. And now we can write the induced current I is equal to epsilon divided by R, 0.24 divided by 4, that is equal to 0.06 ampere. Okay, this is what induced current value. So we got the answer for this. Is the easier one. And here the note is given. The produced EMF, induced EMF is relative orientation between the coil and the magnetic field. And we can achieve this by rotating coil in a magnetic field or by rotating the magnetic field when the coil is in stationary. We can do this in both the ways. Okay, this method only we are using this generator or motor. So about the rotation and how it is changing the EMF and how it is playing the important role, we'll discuss that in upcoming topics. Okay, and now we are moving to the topic 4.4.4. It is about production of induced EMF by changing relative orientation of the coil with the magnetic field. Okay, we will discuss about that. And say we having the rectangular coil. So what we are having, rectangular coil, which is given in diagram 4.24 and 4.25, and this coil having n number of turns of the coil. Okay, n turns. So in the coil பார்த்தா number of turns இருக்கும், இது diagramல காட்டல. n number of turns are wound on this rectangular loop, which is placed in a uniform magnetic field B vector, which is shown in the figure 4.24 and 25 also. Okay, and now the coil is rotating in anticlockwise direction. Say its angular velocity is omega about an axis. It is perpendicular to the field and to the plane of the paper. At time t is equal to 0, the plane of the coil is perpendicular to the field and flux linked with the coil has maximum value. The value of flux phi m is equal to nba, and here a is called as the area of the coil. So what is A? A is called as the area of the coil, and then we can write, so here everything is given. So first we'll see the theory part of this. And in time t second, the coil is rotated through an angle omega t. So we know omega is equal to theta by t. So we discussed in 11th, omega is equal to what? Theta divided by t. Then what is theta? It will be taken as omega t. And now it is rotating in the anticlockwise direction. The flux linked with this is NBA cos omega t. Okay, and it is due to the component B vector normal to the plane of the coil. The component B sin omega t parallel to the plane, so it has no role in electromagnetic induction. Therefore, the linkage of flux with the coil in the reflected position we can write here as n phi b. So total number of turns or compare பண்ணும்போது that we can write as n phi b is equal to nba cos theta. So what is the equation? We can write as nba cos theta. And now what is theta? So theta we know is equal to omega t. That is substituted in this. So nba cos omega t. And as per Faraday's law, the EMF induced in that instant we can write as epsilon is equal to minus d by dt n phi b. And we are substituting the n phi b here, minus d by dt n phi b is nba cos omega t. Okay, and now nba is brought forward, then d by dt cos omega t can be written as minus sin omega t of omega. Then minus and minus will become plus, then the equation will become nba omega sin omega t. When the coil is rotated through the angle 90 degree from its initial position, then sin omega t will be taken as 1. Then the maximum value of the induced EMF is 1, means we can write epsilon m is equal to nba omega. Have you understood, children? So maximum value we are getting sin omega t is equal to 1. Then epsilon m is equal to nba omega. So therefore the value of induced EMF at any instant we can give as epsilon is equal to epsilon m sin omega t. Okay, so this formula is saying that EMF varies as sine function of the time angle omega t. Okay, the EMF epsilon is varies as a sine value of time of angle omega t. Then the graph between the induced EMF and time angle of one rotation of the coil will be a sine curve, and the EMF varying in this manner is called a sinusoidal EMF or alternating EMF. That is shown in the figure 4.25. And check out the 4.25. For each and every rotation of the coil, the curve is given. And see the curve, it is look like it is both the placed in both the positive and negative side. It is giving the alternating EMF. So for this portion, it is reaches to maximum. So this portion of the rectangular, it is goes down. It is deeper to negative, and maximum in negative side. Again, it comes to 0. So the different portion of the rectangular, how the EMF is produced in that is explained with the help of this graph. Okay, this graph is saying that. Have you understood, children? And in this alternating voltage, which is given in the closed circuit, this varying current is called as alternating current. That we can give the formula like a EMF. For EMF we are giving in the equation 4.22 is epsilon is equal to epsilon naught sin omega t. So like that we can give the current value I is equal to Im sin omega t. So this Im here, it stands maximum value of induced current. So what is Im? It is nothing but maximum value of induced current. Okay, and now, so this is till now we discussed about the rotation of the coil in which is placed in a magnetic field. Okay, so after that we are having the example here, and this example 4.15 is based on the rotation of the coil which we discussed now. Okay, so here this rotation, this sum is explained, this question is explains here. A rectangular coil area is given 70 cm square. Its turns are 600 turns, rotate about the axis perpendicular to the magnetic field, 0.4 Weber per meter square. If the coil completes 500 revolution in a minute, we have to calculate the instantaneous EMF when the plane of the coil is, 3 cases are given. One is perpendicular to the field, second is parallel to the field, and third one is inclined at 60 degree with the field. So these 3 cases are given. We have to find out the instantaneous EMF. So in this solution we are taking the data at first, The area is given in this is 70 into 10 to the power minus 4 meter square. And number of turns capital N is 600 turns. And magnetic field it is placed is 0.4 Weber per meter square. Then frequency is 500 revolution per minute. Okay, 500 revolution per minute. So everything is given. The instantaneous EMF formula is taken here. Epsilon is equal to epsilon m sin omega t. Okay, then epsilon m is equal to, we can write the formula n phi m into omega. Then we are expanding the phi m. So phi m oda formula நமக்கு நல்லாவே தெரியும். That is BA cos theta இருக்கும்ல, cos theta will become 1. Then we can write phi m is equal to BA. Then omega we can write here, angular frequency we can write here as 2 pi into f. இதுவும் நம்ம 11th லேயே படிச்சிருக்கோம். Then epsilon we can write here as NBA into 2 pi f into sin omega t. Okay, so what is epsilon here? So இப்போ நம்ம பார்த்தது பார்த்தோன்னா this is epsilon m. This is substituted in this equation. So this equation will become here epsilon is equal to NBA 2 pi f into sin omega t. And first case, what is the first case here? It is perpendicular to the field. Then omega t will be taken as what? 0 degree. So in that first condition we can write epsilon is equal to epsilon m sin 0 is equal to, we can write as 0 because sin 0 is equal to 0. And what is the second one? It is parallel to the field. If it is parallel to the field, the omega t value will become 90 degree. Then we are substituting in this equation. Then epsilon is equal to epsilon m sin 90 degree is equal to, it will become 1. Then what is epsilon m? NBA 2 pi f into 1. The equation will become NBA 2 pi f. And there is a substitution. So number of turns is 600 and B is placed is 0.4 and area is 70. It is given in centimeter square, that is converted into what? Meter. Then it will be taken as 10 power minus 4. Then 2 is constant. Then pi value we know 22 by 7 r. We can use 3.14 into frequency revolution per minute is 500. But here it is given as 500 per 60. It is converted into what? Second. Okay, in per minute 60 seconds are there. So 500 divided by 60. We are solving everything. It gives the answer of 88 voltage. So EMF is given is what? 88 voltage. Then third one is inclined at an angle 60 degree. So inclined at an angle 60 degree means that is subtract with the perpendicular 90 degree. Then the angle is 30 degree here. That we are substituting in this equation. So epsilon is equal to epsilon m sin 30 degree. So what equation we got here? Epsilon is equal to epsilon m sin 30 degree. Sin 30 is nothing but 1 by 2. Okay, then epsilon m value just now we got. So what is the epsilon value we got in this derivation? That is 88. 88 into 1 by 2, that is 44 voltage. So we got for all the three conditions. The first condition is perpendicular to the field, and second one is parallel to the field, and third one is inclined at 60 degree with the field. So we got the answer as 0, 88 voltage. In that half 44 voltage for answers of this given question. Okay, have you understood, children? And in today's class we started and we discussed about the important topic 4.4.4. Okay, so that explains the production of induced EMF by changing how the rectangular changing in the magnetic field and what are the effects it is giving. We have started with the time from 0. Okay, and that moment of the rectangle give the graph that is called as alternating EMF graph. So it is producing the AC. And ஒவ்வொரு பொசிஷனுக்கும் என்னென்ன வேல்யூ கிடைக்கின்றதை we can find with the help of formula. So two important formulas we derived. One is epsilon is equal to epsilon m sin omega t. Another one is I is equal to im sin omega t. So for instant EMF or alternating EMF, we can use the formula epsilon is equal to epsilon m sin omega t. For instantaneous current or alternating current, we can use the formula I is equal to im sin omega t. So different position எவ்வளோ voltage எவ்வளோ current இதில் create ஆகுன்றதை with the help of example 4.15 we understood very clear. Okay, and இதுவும் important topic. The 4.4.4 is more important because இதை பேஸ் பண்ணி தான் நம்ம வரப்போகிற 5 மார்க்ஸ்லாம் டிஸ்கஸ் பண்ண போகிறோம். If you understand this, then the coming part is also easy for you. Then you write, you take down for today's homework from considerல ஆரம்பிச்சு இந்த diagrams-ஓட எல்லாமே, okay, this diagram also up to you have to write this end of this part. Okay, இந்த 5 மார்க்கை ஃபுல்லாக தரவு பண்ணிக்கிங்க. ஸோ டெரிவேஷன் பார்த்தீங்கன்னா ப்ரீவியஸ் டெரிவேஷன் தான் நம்ம எடுத்திருக்கோம். ஓகே, ஸோ N5B NA cos 3 எப்படி எக்ஸ்பேண்ட் ஆகுது, தென் ஃபேடேஸ் லாஸ் எப்படி யூஸ் பண்ணுறது. ஓகே, அண்டு ஃப்ரம் 11th நம்ம ஒமேகா எப்படி எடுத்துக்கிட்டோம், தீட்டா பை டி எப்படி எடுத்துக்கிட்டோம், எல்லாமே நம்ம இதில் டிஸ்கஸ் பண்ணியிருக்கோம். வி காட் ஆல்டர்னேட்டிங் EMF அண்ட் ஆல்டர்னேட்டிங் கரண்ட் வேல்யூஸ். அதை ஃபுல்லாக தரவு பண்ணிவிட்டு தென் யூ ரைட் இன் யுவர் ஹோம்ஒர்க் பார்ட். அதை ஃபோட்டோ எடுத்து என்னோடய வாட்ஸ்அப் ஐடிக்கு யூ சென்ட் யுவர் ஃபோட்டோ இமேஜஸ். Okay, and rest of the topics we'll discuss in next class. Next class we'll start our important topic, AC generator. Okay, so how it will be function, what are the important topics, நம்ம இதை 10th படிச்சிருக்கோம். பட் இப்போ 11th இந்த 12th அப்டேஷனில் இட் கேவ் சம்திங் டிஃப்ரெண்ட். 10th படித்த மாதிரி சும்மா எக்ஸ்பிளைன் பண்ணாமல் it explains very clearly. Okay, so about that we'll discuss in our next class. Thank you, children.